Hello, my name is Martin Fahn, and I am a Solutions Architect with Catalogic Software. And welcome to the demo video series. In this demo series video, we're going to be discussing the advanced recovery features available within our data protection software, DPX. So DPX uses snapshot technology in order to protect data on your critical servers throughout your enterprise using block-level incremental transfers of data to either a NetApp secondary storage destination or an open storage server. It supports both physical and virtual machines and provides support for both NetApp and non-NetApp storage as destination devices. The restore features that we'll be discussing today are instant access, virtualization, and bare metal recovery. Both instant access and virtualization recovery features are patented by Catalogic Software. So with that said, let's just take a look at the environment that I'm running and that we'll be using to demonstrate this feature functionality. So you can see here that I'm virtualizing an entire DPX enterprise on my desktop. I have my master server, which is essentially the brains of the operation. This is going to store the central catalog as well as coordinate the backup events between my clients and my destination storage device. The next server that I'm virtualizing is an open storage server. Alternatively, this can be a NetApp device, but this is going to be my backup destination. So my open storage server is a Windows 64-bit machine with, of course, plenty of disk space, either direct attached storage or SAN attached storage that I can store and protect my snapshots to. Finally, I'm virtualizing a standalone ESXi host, and this will be pertinent for recovering data through my virtualization restore. So let's take a look at my master server. In my master server, I have the DPX management console open, and I've already run a few backup policies and protected a few servers. Now, if I want to recover from any of those servers, I would just simply drill down into that server environment and into the volumes that I want to recover. And you can see here as I drill down to the C drive of this master server that I snapshotted, I see two recovery point snapshots. And each of these recovery point snapshots are referenced as virtual full images, picture point in times of exactly what that C drive looked like when we had snapshotted it. So if I want to restore a folder or a single file or the entire volume, I can just simply select that folder or that file on the left-hand side here, and on the right-hand side select the destination where I want to restore that file to, either back to the original location, or I can create a new location directly through the GUI. Now that's just a simple file level restore, but we call these multi-purpose snapshots. Right, you're able to recover data from these snapshots in a multitude of ways. The first method being perhaps the most useful is our instant access recovery. Now, instant access allows us to present a snapshot up as a read-write LUN to any server in the enterprise. So for example, if I want to map a snapshot of my drive layer C to a server in my enterprise, I could just simply select that snapshot and right-click, select map. Let's map this snapshot back to the master server as any available drive letter, let's say drive letter K. Now within a few seconds, what I should see here is a new drive letter pop up on my master server. You can see a new drive layer being formed. And what's actually happening in the background is on my open storage server, I'm creating a LUN which is backed by the image of that snapshot. So you can see that that C drive has now been mapped to drive layer K. I now see a drive layer K appear through Windows Explorer on my master server. Now this is going to be a read-write LUN. I can copy files from this LUN. I can add files to it, delete files from it, all without having to worry about affecting the integrity of that read-only snapshot. And whenever I'm finished with that mapping, I can just simply right-click on my master server, issue a show map drives, and should see that the K drive is currently mapped on the server. I can just select unmap to dissolve the LUN off of my open storage server and log out the iSCSI target from my master server. So now I should no longer see a drive letter K through my Windows Explorer view. So the next recovery feature is going to be our server imaging features. Now, instant access is very useful in the event that we want to recover a single file or an application or, let's say, an entire volume back to the server. But what if we weren't able to boot up that server? Let's say we couldn't access the operating system, we couldn't access the backup agent or the iSCSI initiator running on that client. In this case, you're in a situation where we would likely need to do a server imaging restorer. And DPX provides two types of server imaging restorers, one of them called Virtualization and the other one called bare metal restore. Now I'm going to go through virtualization first because that is the easiest way in which we can bring up an entire server in just a few minutes. Virtualization, what it entails is taking any snapshot and making it into a virtual machine. Okay, and I can start the virtualization process. This is a restore job that I would create from the master server, and I can run it on a regular scheduled basis. This BMR object represents the operating system for my client servers that I backed up. And you can see if I expand that BMR object, I can see recovery point snapshots that represent that operating system. I also see a latest recovery point. I can schedule a restore job or an instant virtualization restore job that brings up an entire virtual machine as a snapshot using the latest recovery point that I replicate over to my disaster recovery site. I can go ahead and select this BMR snapshot, and if I right click I can see a new context menu which will allow me to virtualize that machine. Now virtualization comes in two different flavors, instant and full virtualization. So we'll go into details of what instant and full virtualization mean a little bit later on, but I'm going to choose instant virtualization. That's going to allow me to bring up a machine within a few minutes because it's going to combine the best of both worlds of bare metal restore and instant access recovery, essentially providing LUNs off of my open storage server and allowing me to map to those LUNs from my ESX host to boot up the machine directly. I also have the option of starting that VM after it's created, but I'm going to point this to my ESXi host that I'm currently virtualizing, and upon browsing into that ESX host I can bind this machine to a specific network, iSCSI adapter, or associate with a VM folder. I can define how I want this machine to bind to my network either through dynamic or static IP address scheming. And I would also need to select a virtualization proxy node through which I want to coordinate these events through. Now, by default, the master server is also a virtualization proxy node type, and I can choose that as my virtualization proxy server. And virtualization proxy server is just simply a server that allows me to coordinate the events between the master server and my virtual infrastructure. But in this case, I can review the summary screen, I can confirm that all my parameter settings are correct, and I can save out this this restore job to be executed by my master server. Now I can schedule this restore job, as I mentioned, on a recurring basis if I were using that latest object to recover from, but in this case I'm just going to go ahead and run this restore job now. And as the restore job is running, I have a vSphere client open where we can see some of the events that are being sent to my virtual infrastructure from the DPX master server virtualization proxy node to create that virtual machine and establish all the raw device LUN mappings. So just jumping back to the differences between the types of virtualization restore, we have what's called instant virtualization, which we're running right now. We're presenting up LUNs from our open storage server, so it's seeing where the snapshot resides on my open storage server. It's creating a temporary data store that's going to present to my ESX host, and you can see my ESX host currently doing a rescan of any HBAs or iSCSI LUNs out there. That's instant virtualization, and because we're not moving any data over the network, it's going to work in the same exact manner as instant access, where we can bring up an entire snapshot as a virtual machine, just like we brought up a snapshot as a read-write LUN near instantaneously. What full virtualization entails is the ability to create the virtual machine but copy all the data from the snapshot into local VNDK files accessible by the data store of your choosing. Now, you'd want to use full virtualization, especially if you were, let's say, restoring machine to production and you needed the most efficient use of I/O storage. However, if you just want to bring up a machine in test mode very quickly, instant virtualization is the way to go. Now, combining both instant and full virtualization is going to lead to what we call as rapid return to production, or an RRP. So this is combining the best of both worlds of instant and full virtualization. We'll perform an instant virtualization immediately followed by a full virtualization in order to bring up the machine quickly, but at the same time, once the machine is up, perform a storage vMotion migration in the background of those dataset resources back to an ESX data store, so that when all is said and done, you have a machine up and running, but in the background, the machine is actually restoring itself back to a local ESX data store. So as you can see here, while I was talking, you can see our virtualization restore is running. You can see that our virtualization proxy server is actually creating or sending the commands to create that virtual machine for us. And the machine is currently booting up, and we're just going to wait for this machine to come online. So at this point, I'm just going to pause the video and come back in a few minutes. So coming back from this few-minute break, you can see that my virtualization restore job has completed. I have my master server as a virtual machine on my vSphere client here, and you can see that instant virtualization literally took only that few minutes to bring up. So again, we're taking that snapshot, making it into a virtual machine. My job kicked off at around 9:20. You can see here that finished within 6 or 7 minutes or so. And now the end result is a virtual machine that has raw device mappings pointing to LUNs exposed by my open storage servers. So these hard disks representing my C and my D drive on my master server are actually mapped raw LUNs presented by my open storage server. Again, instant recovery in a few minutes or less because we're not moving any data over that network. The final restore type is BMR. So BMR is another server imaging restore, but it's a little bit more flexible in that you can recover to virtual machine or physical machine. It also doesn't require the master server to run, so technically speaking, you can do a BMR of the master server. What BMR entails is a copy of that operating system snapshot down onto blank hardware. Right, so this can either be a physical or a virtual machine. In this case, I have a virtual machine setup called BMR, and it's pretty much an exact replica of these other machines that I'm virtualizing in my enterprise. The only caveat being is that it doesn't have an operating system installed on it. Right, so you can see it trying to boot up over the network here, and ultimately it's going to time out and tell me that an operating system has not been found, and to install an operating system. Now, if you think about the steps that are required for rebuilding an entire system, right? You have to install the operating system. You'd have to install OS patches and service packs, applications, even a backup agent just to get to the point where you can start restoring your critical data. But because these are multi-purpose snapshots, we can take any one of these snapshots on our open storage server and lay them down on top of a blank machine through this BMR process. And how we do that is we provide you with a BMR ISO image. And this BMR ISO image is going to provide you with the necessary network connectivity device drivers so that we can communicate with the hardware devices running on this server so that we can lay down our snapshot image, partition the disk so that it meets the exact specification of the original snapshot. Now, you can see in booting up in this BMR ISO image, I'm given the choice of which kernel I want to boot up into. I'm going to choose a Windows 32-bit kernel. We provide one CD for Windows. We provide another CD for Linux. So there's just 2 CDs. You don't have to build CDs of your own per server. You just need that one Windows CD. And this CD is going to boot up, as you can see, in this WinPE kernel, which is going to find all the necessary device drivers to bootstrap your network interface card, your mass storage controllers, because those are the 2 most critical components that we'll need to have in terms of this BMR process. We'll need to be able to read and write data to that disk. We'll need to be able to partition it, and we need to be able to connect to the network, of course, to copy the snapshot down from our open storage server. So that's exactly what this BMR wizard is going to allow us to perform. It's going to boot up into this WinPE kernel, detect those underlying hardware devices, and load those device drivers. So you can see our BMR wizard is starting up here, and we have network adapter has been found. It's already been able to establish an IP configuration over DHCP, and we also have detected disk drives. So we have everything that we need in order to perform this BMR, but some other inconsequential device drivers, 3 devices, might not be functioning correctly. They're not going to be critical to BMR process. You can load those device drivers at a later time. But if you wanted to install a device driver, let's say we did have a disk or array controller that we weren't able to detect the underlying disk of, we can download that device driver and put it to a USB key and point our BMR wizard to that device driver, to that INF file, so that we ensure that we can see that disk drive properly. But in this case, I have everything that I need to connect to the network to read and write data to disk. I'm going to go ahead and log into my open storage server using the local administrator username and password. And from here, it's going to connect to that open storage server, and I can select the drive letter where I have these recovery point snapshots residing. So that would be drive letter F, and I can choose the servers that I want to recover. Let's say I want to recover that production Win server, and I can choose a recovery point snapshot that I want to recover from. So let's just choose this latest point in time, and it sees that there's a C and a D drive available within the snapshot. Now I need to restore my system boot partition or my C drive. It's optional for me to restore my D drive, and my D drive is relatively small, so I'm going to go ahead and restore both those drive letters during this entire process. Now, what BMR is also going to do is confirm that my destination machine is capable of accommodating the snap from or my source side snapshot, so these disk partitions here. Now in this case, these partitions are smaller than the 45 gig per disk sizes that I have on my BMR machine, but if they were larger, let's say, I can shrink these partitions down to the usable space to ensure that it meets the necessary disk sizes on this destination machine. But in this case, I'm just going to go ahead and drag and drop disk 0 to my destination machine disk 1, and the same for disk 1. Go ahead and click next here. Now at this point, this is the last screen of the BMR wizard. I can go ahead and click proceed, but there's one checkbox here that I want to discuss in further detail, and that is this hardware adjustment. And what we can do is perform a hardware adjustment on the fly, essentially do a Windows repair after our BMR has completed. So if you've ever tried to mirror a disk or a hard drive, it's kind of like ripping out the hard drive from a Dell machine and putting it into, let's say, a machine of another type, an HP machine. Now in this case, if you ever try to do that, you'll know that the machine will likely blue screen on you. And the reason for that is because the device drivers that are loaded into that operating system image are not going to be compatible with the hardware that you're now loading that hard drive into. With this perform hardware adjustment, we're able to support restores to dissimilar hardware by re-injecting the device drivers found within the new server back into the OS image. It's kind of like doing a Windows repair on the fly, so that when you remove the CD and reboot the server, you're not going to have that blue screen for you. So now at this point, we're running our BMR restore. You can see that this is a block for block restore at line speed. We're just partitioning the hard drive, laying down the blocks exactly as they appear within the snapshot. So when all is said and done, all we need to do is remove the CD, reboot the server, and our BMR restore process is completed. So I'm going to pause the video for another few minutes here. This restore process continues, and I'll be back in a few minutes. So coming back from the break, you can see that my bare metal restore has completed successfully. I can just simply click OK, and you can see it doing its repair operations prior to rebooting the system. I can simply just restart this machine now after removing the CD, of course, but in this case I have my machine configured to boot up directly off the hard drive as first priority. So you can see it booting up into that Windows operating system for my ProdWin server. So this concludes the demonstration video on the advanced recovery features of Catalogic Software's DPX. In this video we discussed the three recovery features: instant access, instant virtualization, and bare metal restore, with instant access and instant virtualization being patented technologies by Catalogic Software. We thank you for your time and attention, and if you have any questions, please visit our website at www.catalogicsoftware.com. Thank you.